Alright, so let's look at terminating and repeating decimals. So this lesson is more of looking at the vocab and then applying it to the different sections throughout the chapter. So I'm going to walk you through a few examples. So a repeating decimal. No matter how many zeros you write in the dividend, the division just keeps going on. So the same digit repeats. It doesn't have an ending, and you never get a remainder of 0. So if you think about dividing decimals, remember, we cannot have any remainders. Well, these ones, your repeating decimals, what happens is when you start dividing, you're going to see a pattern. You're going to get the same number over and over and over again, and you may never reach an end. So what we are going to do is we're going to stop once we see that pattern. We're going to put a line over those repeating numbers and move on. A terminating decimal is more of what we've been dealing with. A terminating decimal has a definite number of decimal places. When you divide, you get a remainder that is 0. Right? So this is what we've been working with. Terminating, you may not have known what it was, but that's what it's called. And a repeating decimal, once again, is where you don't get an answer. Well, you get an answer, but you don't get that 0 remainder that we've been working with. So once again, to make a repeating decimal, you are going to put a bar is what the book uses. It just simply means you're putting a line over the numbers that repeat. So for example, here we have 0.11111, and a lot of times you will see little dots at the end. That means that 1 is repeating, never ending. So we're going to shorten that up. Instead of writing those ones, because I know a lot of you don't want to write more than you have to, we're going to put our 0 again, 0.1, line over it. Now, if you have a whole number in front instead of a 0, you still put that whole number in. Okay? Do not put that line over the numbers that do not repeat. So, same over here. We have 0.09090. Should be another 9 there. Repeating. So, rather than write those again, we're going to shorten it to be 0.0. I got those backwards, sorry. 9. And put our line over it. So, let's look at terminating decimals from fractions. Sometimes you are going to be given a fraction and you're going to be asked to turn it into a terminating decimal. So first off, we are going to have to go back and look and see what a terminating decimal is. And that is the one where it has an ending. So our fraction is 13 over 20. So based on that definition, we know this is going to have an ending. If you see a pattern with these ones that we know are terminating decimals, you need to go back and check your division. So our denominator goes outside the house. Our numerator is going to go inside the house. So I already have this worked out. So 20 goes into 13 0 times. We write our 0 up here. So we subtract 0 from 13. We get 13. Now, since we notice it's terminating, we're going to go up and add a 0. Bring it down. 130 divided by 20 is 6 times. So 6 times 20 is 120. Subtract that, we get 10. We have a remainder, so we're going to go back up, add our 0, drop it down. 100 divided by 20 is 5. Subtract 100, we get our 0 remainder. So our answer is 0.65. Okay, sorry about the mess on this one. My pen drug all over the place. So we're going to do 6 1/4. So we are going to ignore this whole number, so we're going to pretend like the 6 isn't there for a minute. We'll come back and deal with that here in a second. So we are going to set up our problem. So our denominator is outside once again, numerator in. We're going to work it out. So 4 goes into 1 0 times. So 1 minus 0, 0. Add our 0. Drop it down. We get 10. 4 goes into 10 about 2 times. So we write it up here. 4 times 2 is 8. 8 10 minus 8 is 20. Write our 0 up here again. And 4 goes into 25 times, so 20 minus 20 is 0. We have our nice remainder of 0. We know this is terminating because it says in the directions. So our decimal part is 0.25. Now we have to bring in our whole number. So we're going to add 6 plus 0.25 to get 6.25 for our final answer. Alright, so our last part is we're going to look at repeating decimals. And this is going to follow the same setup as our terminating. You're going to divide like that. But the only difference is you're not going to get 0 for a remainder. So let's look at 1/3. And some of you probably already know this in decimal form. You probably have it memorized, some of you, not all of you, and that's okay. So we're going to put our 3 outside, 1 in. I already have it worked out. So 3 goes into 1, 0 times. 1 minus 0 is 1. We write a 0 up here. So we have 10. Goes into 3 times. 3 times 3 is 9. So we subtract 10 from 9. 1, 0. So once again, 3 goes into 10 3 times. 9, 10. We see a pattern forming. So that pattern starts and we stop. So we have 0.33, and if we were to keep working this out, it would keep being 0.33333 and so on. So we're going to stop there. We're going to leave our 0, put our decimal, our 3, put our line over our 3. Now if you have more, say if you have like 3 3s on the other side of your decimal, that's fine, and you have that line, it's still correct. But if you didn't have this line over here, this will be incorrect. Alright, so we're going to look at a repeating decimal mixed number. So we have 15 and 2/3. It's going to follow the same setup as our terminating decimal. We're going to pretend like the 15's not here for a little bit. We'll come back and deal with that here in a minute. So we're going to divide it out. So 3 goes out, 2 in. So 3 goes into 2, 0 times, subtract 0. We get 2, add a 0, 20. 20 goes in the 3, 6 times. 3 times 6 is 18. We get 20 again. So we'll go one more time. So 20, so 3 goes in the 20, 6 times, 18. We can see that pattern starting. Pattern starts, we stop. So we have 0.66, and if we were to keep solving that, once again, that 6 will keep going on forever and ever. So we're going to do 0.6, put a line over our 6, and we're done with the decimal. So to bring our whole number in, we're going to bring our 15 in, plus 0.6, add that, we get 15.6, line over your 6 to show it's repeating.